Hello everyone, welcome back to my channel. My name is Anton G. Tolosa. So for this day, we will do the all activity in NetAcad, which is in chapter 7. But before that, we need to read the introduction of this chapter. So we go to chapter 7, IP addressing. Addressing is a critical function of a network layer protocol. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4, IP version 4, and Internet Protocol version 6 or the IPv6 provide hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. This chapter examines in details the structure of IP addresses and their application to the construction and testing of IP network and subnetwork. So we are done introduction of this chapter. So we go to the activity of this chapter. So we will find it here. Okay. In topic 7.1.1.1.1 binary and decimal conversion. So this. So the title of the activity is binary to the decimal conversion activity. So the instruction of this activity allow you to practice 8 bits binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So this problem. To sorry, but I'm not good in mathematics. So to easily to answer this, we need to use the powerful tools, which is the calculator. That's why we can easily answer it. Okay. Okay, the bits is 0 1 1 1 0 0 1 0. So the 1 is in 64, so we need to type 64 here. Then plus the 32, the 32, 32 plus the 16, plus the 16. Then 8 is 0, then 4 is 0, then 1 is 2 plus 2. Then the answer will be 1114. Okay. Okay, next new number. Okay. I'll delete it. So the number is in the 1 is in 64. Then the 1 is in 32. Then the 1 is in 16. Then the 1 is in 8. Then the 1 is in 2. And the 1 is in 1. So 123. The answer is 123. Okay. Then next new number. So the here is 0, 128 is 0, 64 is 0, 32 is 0, 16 is 0, 8 is 0, 4 is 0, 2 is 0, and 1 is 0. So there's no 1 here, that's why the answer will be 0. Okay, we are done in this activity. We go to another activity here. Okay, so this activity is name is decimal to binary conversion activity. So So the instruction of this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with these tools until you are able to do the conversion without error. Convert the decimal number shown in the decimal value row to its binary bits. So the binary here is okay. So the decimal value is 20. So 128 will be 0 because 20, then it will be 02, then this is 02, 16. So 16 is in 20, that's why it can be 1 here. 16 plus 4, it will be 20. So that's why the another part of this bit will be 0. Okay, check. Okay, new number 136. So 128 is in 136. 1 well 128 plus 64, it will not be 136, that's why we can, it will be 0. Then 128 plus 32, it not will be 136, that's why it will be 0. Then 128 plus 16, it not will be 136, that's why it will be 0. Then 8 plus 128, so it is will be 136, that's why it will be 1. Then the another is will be all 0. Okay, next new number 153. So 128 plus 64 is not 153, that's why it will be 1, then it will be 0. Then 128 plus 32 is not will be 153, that's why it will be 0. So 128 plus 16, wait lang, 128 plus 16, it will be 144, so it will be 1 here. 144 plus 8, 152, then it will be 0, 0 and 1. Okay, we are done in this activity. So we go to topic 7.1.2, IP version 4 address structure. So we need to find the activity here. So the activity name is ANDing or AND to determine the network address. So the instruction of this activity is to use the ANDing process to determine the network address in binary and decimal format. Okay. So the host address is 172.29.254 and 155. Then the subnet mask is 255.255.128 and 0. So in binary it will be 10, 1, 10, 10, 11, 11, 0, 0, which is the 172, and 255, which will be 1, 1, 1, 1, 1, 1, 1, 1. Okay. So in this activity, so 1 and 1 is equals to 1. 0 and 1 is 0. 1 and 1 is 1. So the in truth table, if 1 is 1, then it equals to 1. 1 and 0, it equals to 0. 0 to 1, it is equal to 0. And 0 to 0 is equals to 0. Then 0 to 1 is 0. Tapos 1 to 1 is 1. 1 to 1, wait lang. 1 to 2, 3, 4, 5, 6. 1 to 1 is 1. 0 to 1 is 0. 0 to 1 is 0. Okay. Then 0 to 1 is 0. 0 to 1 is 0. 0 to 1 is 0. 1 to 1 is 1. 1 to 1 is 1. 1 to 1 is 1. 0 to 1 is 0. And 1 to 1 is 1. Then 1 to 1 is 1. 1 to 0 equals 0. 1 to 0 to 0 equals 0. 1 to 0 is 0. 1 to 0. It's all 0 here. Okay. Then it all 0. That's why it will be 0, 0. Okay. So network address in decimal. So the 8 bits here is the 1 is in 128 plus 32. Okay, we need the calculator here. That's why we can easily answer it. Okay. So 128 here, this one, then it's the another is 1 is 32 plus 32 plus 0, 16 plus 8 plus 1 equals 169. 169. Then oops, 1 plus 2, 4 plus 4 is 5 plus 8, 13 plus 16. 13 plus 16 is 29. 29. Tapos it will be 128 here. Tapos it will be 0. So incorrect. Oh, sorry. Okay, I will fix it. 128 plus 32. Wait. 128 plus 32. Wait lang. 1101 1100. 128 plus 32 plus 16, 32 plus 8 plus 4, 172 here. Sorry for the mistake. Okay, new number. So the host address is 10, 19, 65, and 213. The subnet mask is 255, 255, 255, and 224. So the host address in binary is 000010, 10, then 0001, 0011, 01, 000001, and 11, 01, 0101. In subnet mask in binary is all 1, all 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0. So network address in binary. So 0 and 1 is 0. 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 1 and 1 is 1. And 0 and 1 is 0. 1 and 1 is 1. And 0 and 1 is 0. Oops. 2, 4, 6. 2, 4, 6. 1, 0. Then it will be 0, 0, 0, 1, 0, 0, 1, 1. Then 0, 1, 0, 0, 0, 0, 1. Tapos 1, 1, 0, 0.0000. So in decimal, so it's 1, 2, 4, 8, 16, 32, 64, and 128. So the 1 is in 4, is in 2. 2 plus 8 is 9. 9 here, the answer. Kasi, because 2 plus, wait, no, 8 plus 2 equals 10. 10. Sorry, I'm not good in mathematics. Then, 1 plus 2 is 3. Tapos, 2, 4, 8, 16. It will be 19. Then, 64 plus 1 is 65. So, it's like this. Tapos, 128. 128 plus, oh my god, 128 plus 64 is equals to, oh, 128 plus 64 is equals to 192. 192. 192. Ay, sorry, I'm not check it. Sorry, I'm not. Okay, we will do the another. 1 0 1 0 1 1 0 0 0 0 0 1 1 0 0 0, then 0 0 0 0 1 0 0 0, tapos 0 here. Then the binary is 128 plus 32. 128 plus 32 plus 8 plus 4. Oh, why the answer will be 128 plus 32 plus 8 plus 2, 170. 170 here. Tapos 1, 2, 4, 8, 16. 8, 16 plus 8 is 24. It will be 8 and 0. Incorrect. Why? Okay, 1. Oh, sorry. It will be 2. Sorry. It is 4, not 2. Sorry. Okay, we are done in this activity. So we go to topic 7.1.3, IP version 4, unicast and broadcast. If there's an activity here, so there's no activity here. Then we go to topic 7.1.4, topic of IP version 4 addresses. So the title of this activity is pass or block IP version 4 addresses. So the instruction is decide to pass or block each IP addresses depending on whether it is public, the internet, or private small local network. Click start to begin and click on either pass or block. Okay, so if the addresses is the first number is 10.0, 10.55, 10.255, 172.16, and 192.168. So it will be private and it will be black. Okay, we need to start here. So 216 will be pass. Then 928 will be pass. Then 68 will be pass. So it will be pass. Then will be pass. Okay, we are done in this activity. So easy. Okay, we go to another activity here. In section 7.2, IP version 6 network addresses. So topic 7.2.1. So we need this activity. So the activity is IP version 4 issue and solution. So the instruction of this activity is drag the IP version 4 and IP version 6 terms to the field next to the appropriate description. So I need to drag the answer in this. Okay. So 128 bits address 340 undecillion addresses. So it's 128 bits, that's why it will be IP version 6. Then 32 bits addresses 4.3 billion addresses. So it is the keyword is 32, that's why it will be IP version 4. So transport an IP packet over IP version 4 network. Okay. So it will be tunneling. Then uses NAT64 to convert between IP version 4, version 6 and IP version 4. So it will be translation. Then allows IP version 4 and IP version 6 to coexist on the same network segment. So it will be dual stack. Okay, we need to check it. So we are done. So we go to another activity here. 7.22. So in this activity, so the title of the activity is practicing the IP version 6 address representation. The instruction is convert the IP version 6 addresses into short, omit the leading zeros, and compress form. Use the number at the bottom of the page to continue this activity. Okay, so the omit leading zeros will be 2001, then it's all 0, that's why it will be 0 here. Then ODB8, so the 0 will be erased, that's why the remaining will be DB8. Then it's all 1 here, then it will be 0 0 0 and 200. So the compressed format of this is 2001 0, then DB8 and 1111. Then there's a lot of 0 here, that's why we can easily erase that by using this symbol and just add 200 here. So it will be correct. Number 2, IP version 6 conversion. So it will be 2013 0 1 2 3 4 5 6 7 8 9 AB C D E F and 0 and 1. So it will be, so the answer will be that. Okay, it will be 0 0 0 0 0 0 0 and 1. Then the answer will be that. Then 20. So we need to BCD. What we call that? EF01. Oh my god. 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, A, and B. So the compressed format of this is 2012 ABCD EF01. Just copy that. 201 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, A, then B. Okay. So we will answer just only 5 here because it's so there's a lot of activity in chapter 7. So we need to so ABE, then 2B0, then it will be 0, then 1, 2, 3, 5, okay. Oh, why it's incorrect? 113 AB1 to B0. Okay, we need to fix it. So AB1E is 2B 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 1, 0, 1, and 1, 1, 2, and 1, 1, 1, 3. Oh, why it's incorrect? 2B00 2, 3, 9101, then oh, I can answer this. AB1 2500 here. It would not. What is the 2B00 00? Oh, there's a 0 here. That's okay. I can answer the number 5. So we so so we are done in this activity. Sorry if I can answer that. We go to topic 7.2.3 here. So this activity. So the activity name is identify type of IP version 6 addresses. So the instruction is drag the IP version 6 address type to the most appropriate description. So global, unicast, link local, and 64. So unique internet routable IP version 6 address dynamic or statics. It will be global unicast. So FE80113. So it will be link local. Then 2001 DV8, so it will be global. Then technical IP version 6 prefix used to indicate the network version of the address. It will be 64 and used to communicate with others, link local. Okay, we are done in this activity. Okay, there's no activity here. Okay, we are done in the activity in chapter 7. So we go to the summary of this activity of this chapter rather. So chapter 7, IP addressing. IP addresses are hierarchical with network, subnetwork, and host version. An IP address can represent a complete network, the specific host, or the broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The bits within the network version of the IP address must be identical for all devices that reside in the same network. The subnet mask or prefix is used to determine the network version of an IP address. IP addresses can be assigned either statically or dynamically. DHCP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. IPv4 hosts can communicate one of three different ways: unicast, broadcast, and multicast. Also, block of addresses that are used in network that requires limited or no internet access are called private addresses. The private IPv4 address block are 10.0.0.0.8, 172.16, and 192.168. So the definition of IP version 4 address space is the motivating factor for moving the IP version 6. Each IP version 6 addresses has 128 bits versus the 32 bits in an IP version 4 address. IP version 6 does not use the dotted decimal subnet mask notation. The prefix length is used to indicate the network version of the IP version 6 address using the following format: IP version 6 address prefix length. There are three types of IP version 6 addresses: unicast, multicast, and anycast. An IP version 6 link local address and enable a device to communicate with other IP version 6 enabled device on the same link and only on that link subnet. Packet with its source or destination link local address cannot be routed beyond the link from which the packet originated. IP version 6 link local addresses are in FE80 10 range. ICMP is available for both IP version 6, 4, and 6. ICMP version 4 is the messaging protocol for IP version 4. ICMP version 6 provides the same service for IP version 6 but includes additional functionality. After it is implemented, an IP network needs to be tested to verify its connectivity and operational performance. So that's all for today. So I hope you understand my what I'm saying. So see you in my next video and bye bye.